Inequalities. Some problems in algebra lead to inequalities instead of equations. An inequality looks just like an equation, except that in place of the equal sign is one of the symbols, either less than, greater than, less than or equal to, or greater than or equal to. So here's an example of an inequality, and we'll solve that one later. 4x plus 7 is less than or equal to 19. To solve an inequality that contains a variable means to find all of the values of the variable that make the inequality true. Unlike an equation, an inequality has an infinitely many solutions, which form an interval or a union of intervals on the real number line. Right, so equation has one solution or maybe two solutions, but has a finite number of solutions. An inequality has an infinite number of solutions that all lie within one or two or more intervals. So let's look at the steps and we'll come back to this one and some rules. So rules for inequalities. Adding the same quantity to each side of an inequality gives an equivalent inequality. Subtracting the same quantity from each side of an inequality gives an equivalent inequality. So just like when you're solving an equation, right, and if you want to move something from one side to the other, you add the same amount on both sides, or you subtract the same amount on both sides, you can do the same thing with an inequality, no problem. Where it gets to be different is when we multiply an inequality, and specifically by a negative number. So multiplying each side of an inequality by the same positive quantity gives an equivalent inequality. So just like when you're solving an equation and say you've got 1/2 on your variable and you want to isolate, get rid of that 1/2. So you multiply both sides by 2, you can do the same thing here, right? So you can multiply both sides of an inequality by any value you want, right? Until that becomes a negative number, right? So this one is a special one that applies to just inequalities. So you might want to put a star so you remember that multiplying each side of inequality by the same negative quantity reverses the direction of the inequality, right? And we'll just do a little example just to show you, yes, you would have to reverse the direction of the inequality. If not, you're going to have an untrue statement, right? So the only way that you can multiply by a negative number is if you also reverse the sign, have it go the other direction. Taking reciprocals of each side of an inequality involving positive quantities reverses the direction of the inequality. So just like multiplying, and by the way, the same thing applies for dividing, because dividing is just multiplying by the reciprocal. So where it says multiplying, also add in dividing. All right, so taking reciprocals of each side of an inequality involving positive quantities reverses the direction of the inequality. In other words, if A is less than B, then 1 over A is greater than 1 over B. Right? And if we use a number example, you see that would have to be true. Let's just use 2 and 3. So 2 is less than or equal to 3. That's a true statement. But 1/2 is greater than or equal to 1/3. Right? So if you want to use the reciprocals in any way, you've got to change the direction, right? Because if you divide something into smaller pieces, the pieces are bigger. Inequalities can be added, and inequality is transitive. So if A is less than or equal to B, and B is less than or equal to C, well, A has got to be less than or equal to C as well, right? It's less than B, it must be equal to less than C. So if we multiply each side of an inequality by a negative number, we reverse the direction of the inequality. For example, if we start with the inequality, right, so let's say we start with the inequality, let's just do something really, really simple. So 3x, actually let's just even make something, not even an x in it. 3 is greater than 2. Let's just stick with 3 and 2. All right, so 3 is greater than 2. But if I multiply by negative 1, negative 3 is not greater than negative 2. That's not a true statement. But if we flip the inequality, then it is. So if you are multiplying or dividing by a negative number, remember to reverse the direction of the inequality. Otherwise, you'll have an untrue statement. All right, so let's go back to this one that was in your notes. All right, so here, and I'll go through the steps for solving an inequality. All right, so here we have the inequality 4x plus 7 is less than or equal to 19. All right, so first we want to just like before, perform inverse operations. Oops, too many P's in the word operations there. To isolate the variable. All right, so that would be our step 1. All right, so we're going to subtract 7 from both sides, and you can do this one because this one's in your notes. Then we've got 4x is less than or equal to 12. 4x is less than or equal to 12. And now we want to divide. So we can add or subtract anything we want, no problem. We can divide by anything we want, so long as it's that if it's a negative number, right, we reverse the direction of the inequality. Here we don't need to. All right, so we don't need to divide by a negative number. We're not going to reverse anything. So our solution here is x is less than or equal to 3. All right, so just like before, you're going to perform inverse operations to isolate the variable. We'll just make sure we follow the rules, and then we'll graph solution on a number line. I'm going to abbreviate number with the symbol. All right, so we'll just draw it. I've got a line tool, so I'll make it look nice. And actually, I can get a line tool that's got arrows on both ends. Okay. Where's my? All right, where's my? Right, now I got it. There we go. Just took a moment. All right, so, and you can, depending on how you don't have to necessarily graph 0. You can, graph whatever's near yours. You want to show enough number lines so your solution makes sense. Since this number is not very big, I can fit 0 in there. So 0, 1, 2, 3, 4, and -1, -2. That's good enough. Notice it says that x is less than or equal to. So if you have less than or greater than, use an open circle for graphing. If you have less than or equal to or greater than or equal to, use a closed circle. All right, less than or greater than means that the point's not included. Less than or equal to, greater than or equal to means the point is included. So I'm going to graph I'll graph in red. All right, so I'm going to graph a closed circle, right, because it says less than or equal to, and then I'm going to go in the direction. So it says x is less than 3, less than or equal to 3. So it's all values starting with 3 and that are less than 3. And there we go. There's our solution. We're all done, right? So these aren't too difficult to solve when they are linear. And actually in this video, we're just going to be looking at solving linear inequalities. Let's solve another one. So linear inequalities means that the largest exponent is degree 1. So an equality is linear if each term is constant or a multiple of the variable. To solve a linear inequality, we isolate the variable on one side of the inequality sign, right? And then to sketch the solution set, right, we choose either an open circle or a closed circle, depending on if it's less than or equal to, greater than or equal to, or just less than and greater than. So let's look at this one. We have 3x is less than 9x plus 4. All right, so I want to get the x is on one side, so we'll subtract 9x from both sides. And this is in your notes. So 3x is less than 9x plus 4. I'm going to subtract 9x from both sides. 3x minus 9x is a negative 6x is less than 4. Right, so we did our first step. We were isolating. We isolate the variable on one side of the inequality sign. Right? We just have to get rid of the negative 6. Well, I need to divide by negative 6 to eliminate that. And if I divide by negative 6, I need to change the direction of the inequality. So instead of being a less than, it's going to be a greater than. All right, so don't forget to change direction of inequality when multiplying or dividing by negative numbers. All right, so that's going to give us x is greater than, we could reduce that, that's a negative 2/3. And now we're going to graph our solution set. Will I still have my 2 arrows? Well, I got 1 out of 2, I guess. Let's see if I can get it now. Whoop. There we go. I'm going to get rid of this one. Maybe not. Oops. All right, let's get rid of this one. For some reason, it's harder to delete something when it's recording. There we go. All right. So we want x is greater than negative 2/3. So remember, if it's a less than or a greater than, use an open circle. That doesn't look very open. And if it's less than or equal to or greater than or equal to, use a closed circle. So I'm just going to label this. All right, so 0, 1, 2, or negative 1, negative 2, 1, 2. That's plenty. All right, so an open circle at negative 2/3. Oh, about there. Well, there we go. That looks better. And then we want x greater than negative 2/3. So that's going to go in the greater direction. And there we go. There's our solution. All right. So that's all there is to solving linear inequalities when you've got just one inequality sign. We could also have 2 inequality signs to solve for. And this one was actually missing from your notes. So I do want you to add the next problem. And the next problem is the last one I'm going to do on this particular video. And we'll graph it as well. So this is the one I want you to add. You can add it to the last page of the previous concept because that had some extra space on it on that last page. Or you can squeeze it in. But this one is an important one. This is called solving a pair of simultaneous inequalities. What simultaneous means is that there is two inequality signs. And it's pretty much just the same as solving with one inequality sign. Right? Instead of whatever you have to do, whatever you do to one side of the equation or inequality, you have to do to the other side. The only difference is whatever you do to one side of the inequality, you have to do to all three. You have to do to the left side, the right side, and the middle. All right, so let's look at our equation here. We have 4 is less than or equal to 3x minus 2 is less than or equal to 13. Well, I would like to get the x by itself, and I have 3x minus 2. I have a minus 2 with that x. I'd like to get rid of the minus 2. I can get rid of the minus 2 by adding 2. And that's fine. Just remember to add it to all three parts. If you do it to one, you do it to all. So everybody gets a plus 2. So now we have 6 is less than or equal to 3x is less than 15. Now that makes sense. If 3x minus 2 was greater than 6, well, just 3x should, if 3x minus 2 is greater than 4, well, then just 3x should be greater than 6, right? And if 3x minus 2 was less than 13, well, just 3x should be less than 15. All right, and now we have one last thing. We're going to divide all three sides by 3 because we want to solve for x. All right, so we have 2 is less than or equal to x is less than 5. And now we're going to graph it. So notice that x there has to be greater than or equal to 2, but less than 5. Okay. So let's graph that, and you should graph this too. Okay, this time I do have, now I'm going to get an extra one. I'm not going to delete that now. There we go. All right, so there's our number line. All right, and I'm just going to start with 0 this time. 0, 1, 2, 3, 4, 5, 6, 7. So you include a number line too. And so long as 2 and 5 are on that number line, you're okay. So now we have to think about what kind of circle do we want, what kind of point. It's not really a circle, it's a point. What kind of point do we want at each value? Well, we have 2 is less than or equal to x, or x is greater than or equal to 2. So notice that equal is there. This is a closed dot. So at 2, we're going to graph a closed dot. X is less than 5, or 5 is greater than x. Notice there's no equal here, so here we're going to graph an open dot, or an open point. X is sandwiched into between those two values. It's greater than 2, but it's less than 5. And not a very straight line, but there's our solution. I think that looks okay. I'll make the dot bigger, and then it all works out. Right? And that's the last one we're going to do on this video. In the next video, and the next Nearpod, we'll look at solving quadratic inequalities. Right? So thanks for watching, and bye for now.